Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on trigonometry degree level chapter Deductions from D. Moivre's Theorem, lecture number 14, in which I will solve some more problems on limiting values of trigonometrical expressions. Now we solve a problem. Problem is evaluate limit x tends to pi by 2 sin x to the power 10x. Now we solve this. Given that x tends to pi by 2, let x equal to pi by 2 plus y, where y tends to 0. Since x tends to pi by 2 means x is very close to pi by 2. So the value of y will be very close to 0. Therefore, given expression will be limit x tends to pi by 2 sin x to the power 10x equal to limit y tends to 0 sin pi by 2 plus y to the power 10 pi by 2 plus y. This equal to limit y tends to 0 sin pi by 2 plus y is cos y and 10 pi by 2 plus y is minus cot y. This is number 1. Let z equal to cos y to the power minus cot y implies that log z equal to log cos y to the power minus cot y implies that log z equal to minus cot y log cos y, and this will be equal to minus log cos y by 10y. Cot y means 1 by 10y, and we write this minus log cos y. We expand cos y in powers of y. This will be 1 minus y square by factorial 2 plus y to the power 4 by factorial 4 minus dot 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 dot. Expansion of 10y in powers of y will be y plus y cube by 3 plus 2 by 15 y to the power 5 plus 17 by 315 y to the power 7 plus dot dot dot. Taking limit y tends to 0 log z equal to limit y tends to 0 minus log 1 minus y square by factorial 2 plus y to the power 4 by factorial 4 minus dot 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 by y plus y cube by 3 plus 2 by 15 y to the power 5 plus 17 by 315 y to the power 7 plus dot dot dot. We may write this as limit y tends to 0 minus log 1 minus y square by factorial 2 minus y to the power 4 by factorial 4 plus dot 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 by, we take common y here, 1 plus y square by 3 plus 2 by 15 y to the power 4 plus 17 by 315 y to the power 6 plus dot 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 dot. This equal to limit y tends to 0. Here log 1 minus x, this log 1 minus x equal to minus x square by 2 minus x cube by 3 minus x to the power 4 by 4 and so on. And here we have negative sign. So here we will get y square by factorial 2 minus y to the power 4 by factorial 4 plus dot 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 plus y square by factorial 2 minus y to the power 4 by factorial 4 plus dot 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 whole square by 2 and plus dot 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 dot. Here we have y 1 plus y square by 3 plus 2 by 15 y to the power 4 plus 17 by 315 y to the power 6 plus dot 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 implies that limit y tends to 0 log z equal to limit y tends to 0. Here we write y square by factorial 2 minus y to the power 4 by factorial 4 plus dot 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 dot, and from this term we take only one term y to the power 4 by 8 plus dot 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 dot, and here by y multiply 1 plus y square by 3 plus 2 by 15 y to the power 4 plus 17 by 315 y to the power 6 and plus dot dot dot, and this will be equal to limit y tends to 0. Here we take common y, we get y by factorial 2 minus y cube by factorial 4 plus dot 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 plus y to the cube by 8 and dot 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 dot. Here y tends to 0 means y not equal to 0, then y cancel out, only remains limit y tends to 0 y by factorial 2 minus y cube by factorial 4 plus dot 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 dot. Here using limit y tends to 0 we get this is 0 0 and so on, this is 0. Therefore limit y tends to 0 log z equal to 0. Here we have base e implies that limit y tends to 0 z equal to e to the power 0, that is 1, implies that limit y tends to 0 z means cos y to the power minus cot y, and this equal to 1, implies that here in place of y we write x, limit x tends to pi by 2, and in place of cos y we write sin x to the power minus cot y. In place of minus cot y we write tan x, and this is 1. So our problem is solved, which is the required result. Now we solve the next problem. Next problem is evaluate limit x tends to pi by 2 sec x minus 10x. Now we solve this. Here given that x tends to pi by 2. Let x equal to pi by 2 plus y, where y tends to 0. Now we write the problem. Limit x tends to pi by 2 sec x minus 10x equal to limit y tends to 0. Here sec x means pi by 2 plus y minus 10x means 10 pi by 2 plus y. This equal to limit y tends to 0 sec pi by 2 plus y is minus cosec y, and 10 pi by 2 plus y is minus cot y, minus minus plus, and this equal to limit y tends to 0 minus 1 by sin y plus cos y by sin y, and this is equal to limit y tends to 0, here sin y, here minus 1 plus cos y, and this will be equal to limit y tends to 0 minus 1 plus, we expand cos y in powers of y, here 1 minus y square by factorial 2 plus y to the power 4 by factorial 4 minus dot 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 bracket closed by, we expand sin y in powers of y minus y cube by factorial 3 plus y to the power 5 by factorial 5 minus dot dot dot, and this will be equal to limit y tends to 0, here minus 1 plus 1 minus y square by factorial 2 plus y to the power 4 by factorial 4 minus dot 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 by y, we take common y, 1 minus y square by factorial 3 plus y to the power 4 by factorial 5 minus dot dot dot, this equal to limit y tends to 0, Here we take common y square, remains minus 1 by factorial 2 plus y square by factorial 4 minus dot 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 dot. Here y 1 minus y square by factorial 3 plus y to the power 4 by factorial 5 minus dot 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 dot. Since y tends to 0 means y not equal to 0, so 1 y cancels. Here we have y minus 1 by factorial 2 plus y square by factorial 4 minus dot 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 dot. Here remains 1 minus y square by factorial 3 plus y to the power 4 by factorial 5 minus dot 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 dot. Here limit y tends to 0. Using limit y tends to 0, here 0 multiply something 0. Here remains only 1. So numerator will be 0 and denominator will be 1. This is 0, which is the required result, required answer. Now we solve the next problem. Next problem is evaluate limit n tends to infinity cos x by n whole to the power n. Now we solve this. Since our problem is limit n tends to infinity cos x by n whole to the power n. Here n tends to infinity, so x by n tends to 0. So we may expand cos x by n in powers of x by n. This is equal to limit n tends to infinity. Here this is 1 minus x by n whole square by factorial 2 plus x by n whole to the power 4 by factorial 4 minus dot 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 to the power n. Since n tends to infinity implies that x by n tends to 0, and so we have expanded this. This equal to limit n tends to infinity 1 minus x by n whole square by factorial 2 to the power n, neglecting higher order terms. Since x by n is very small quantity, and then if we increase the power of this small quantity, the quantities will be smaller and smaller, and we neglect the higher order terms. This equal to limit n tends to infinity 1. Here we take plus sign, so here will be minus x square by 2 by n square to the power n, and this will be equal to limit n tends to infinity 1 plus minus x square by 2 by n square here we give power n square and to the power 1 by n. So n square multiply 1 by n is n, and this will be equal to value of this is e to the power minus x square by 2 and to the power 1 by n. Since we know that limit n tends to infinity, 1 plus x by n to the power n equal to e to the power x. Here in place of n we have n square, and n square tends to infinity. N tends to infinity means n square tends to infinity. So here n square, here n square. In place of n we have n square, and we have given here to the power 1 by n to adjust the power n. N square multiply 1 by n is n. Here we have n, and here already we have limit n tends to infinity. Here we have n, so here we write limit n tends to infinity, and this will be equal to limit n tends to infinity e to the power minus x square by 2n. When n tends to infinity, this will be 0. This is equal to e to the power 0, and that is 1. So our problem is solved, which is the required answer. Now we solve the next problem. Next problem is prove that limit n tends to infinity cos x by n whole to the power n square equal to e to the power minus x square by 2. This is the similar to the previous problem, only this power is different. So our problem is limit n tends to infinity cos x by n to the power n square. Since n tends to infinity implies that x by n tends to 0, and so x by n is very small quantity. We may expand cos x by n in powers of x by n, which is this. Here we neglect higher order terms because x by n is very small, and if we raise the power it will be smaller and smaller. So we take only up to this term 1 minus x by n whole square by factorial 2, and which is equal to this is 1 plus minus x square by 2 by n square, and we have power n square. Since we know that 1 plus x by n limit n tends to infinity to the power n equal to e to the power x. So this will be equal to e to the power, here in place of x we have minus x square by 2, and proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.